The vestibulocochlear nerve is the 8th cranial nerve. The vestibulocochlear nerve carries special afferent fibers conveying positional sense or balance from the vestibular labyrinth and auditory sense or hearing from the cochlea. The vestibular and cochlear components of the vestibulocochlear nerve are discrete functional units and as such originate from different nuclei in the brain. The vestibular nerve arises from the vestibular nuclei in the pons and medulla, and the cochlear component arises from the dorsal and ventral cochlear nuclei in the inferior cerebellar peduncle. The vestibular nerve and the cochlear nerve join in the pons, forming the vestibulocochlear nerve. The nerve emerges from the brain at the cerebellopontine angle. The vestibulocochlear nerve crosses the posterior cranial fossa and passes through the internal auditory meatus, seen here from far away and seen here in a closer view of the internal auditory meatus on the posterior aspect of the petrous part, the temporal bone. As the vestibulocochlear nerve enters the internal auditory meatus, it travels below the motor root of the facial nerve, separated from it by nervus intermedius, the sensory root of the facial nerve. Within the internal auditory meatus, the vestibulocochlear nerve divides into the vestibular division and the cochlear division. The vestibular nerve provides innervation to the vestibular system, which is responsible for maintaining balance. The cochlear nerve travels to the cochlea of the inner ear, which is responsible for hearing. The glossopharyngeal nerve is the 9th cranial nerve. The glossopharyngeal nerve is primarily a sensory nerve, but it also has small visceromotor, branchiomotor, and taste components. It carries 5 of the 6 fiber types. These are general somatic afferent, general visceral efferent, general visceral afferent, special sense, and branchiomotor. The targets of the somatic sensory innervation include the posterior 1/3 of the tongue, the pharynx, the auditory tube, the middle ear cavity, and the small area of skin behind the ear called the patch. The general visceral efferent fibers carry presynaptic parasympathetic fibers to the otic ganglion, where they synapse and provide innervation to the parotid gland. The general visceral afferent fibers carry interoceptive information from the carotid body and sinus. The special afferent fibers carry taste information from the posterior 1/3 of the tongue. Motor fibers pass to one muscle, the stylopharyngeus, derived from the 3rd pharyngeal arch. Now we will discuss the path of the glossopharyngeal nerve through the skull. The glossopharyngeal nerve originates from 4 nuclei in the medulla: 2 motor nuclei, the nucleus ambiguus and the inferior salivatory nucleus, and 2 sensory nuclei, the spinal nucleus of the trigeminal and the nuclei of the solitary tract. The glossopharyngeal nerve crosses the posterior cranial fossa and leaves the skull through the jugular foramen. Just below the foramen, the glossopharyngeal nerve bears 2 ganglia, the smaller superior ganglion and the larger inferior ganglion. The superior ganglion gives off no branches, while the inferior ganglion gives off 2 branches. Those branches are a small contribution to the patch of skin behind the ear and the tympanic nerve. The tympanic nerve is composed of general sensory afferent fibers and general visceral efferent fibers. The general sensory fibers receive information from the middle ear cavity and auditory tube. The basic path of the tympanic nerve is as follows. The tympanic nerve is given off from the glossopharyngeal nerve in the jugular fossa. The tympanic nerve travels a short distance before re-entering the bones of the skull. It travels within the temporal bone to reach the middle ear cavity, where it forms the tympanic plexus and gives off the lesser petrosal nerve. Sensory information from the middle ear cavity travels along the tympanic nerve to reach the glossopharyngeal nerve. The tympanic nerve enters the skull through the tympanic canaliculus, which is located on the ridge of bone between the jugular fossa and the carotid canal when you look at the skull in an inferior view of the skull base. In order to locate the tympanic canaliculus, turn your skull over into a view of the inferior skull base. Locate the occipital condyle, jugular fossa, and carotid canal. On the ridge of bone in between the jugular fossa and the carotid canal, you should be able to find the tympanic canaliculus. The tympanic nerve travels through the tympanic canaliculus to reach the middle ear cavity. In the middle ear, it is joined by postganglionic sympathetic fibers from the sympathetic plexus on the internal carotid artery. Together, the fibers of the tympanic nerve and the postganglionic sympathetic fibers form the tympanic plexus. The tympanic nerve gives off a branch, the lesser petrosal nerve, which contains only general visceral efferent, preganglionic, parasympathetic glossopharyngeal fibers. The lesser petrosal nerve is given off from the tympanic nerve inside of the temporal bone. It travels through the temporal bone before passing back out into the middle cranial fossa. From there, the lesser petrosal nerve travels along the floor of the middle cranial fossa, exiting the skull through foramen ovale to end at the otic ganglion. Now we will look at each of these components in greater detail, starting with the lesser petrosal nerve passing back out into the middle cranial fossa. The lesser petrosal nerve passes through a gap in the roof of the tympanic cavity called the hiatus for the lesser petrosal nerve, located on the anterior side of the petrous part of the temporal bone. The lesser petrosal nerve exits the middle cranial fossa through foramen ovale. Suspended underneath the foramen ovale is the otic ganglion. The presynaptic parasympathetic fibers of the lesser petrosal nerve synapse on the otic ganglion, and the postsynaptic parasympathetic fibers are distributed to the auriculotemporal nerve, a branch of the trigeminal nerve, for distribution to the parotid gland. The tympanic nerve and the lesser petrosal nerve were branches of the inferior ganglion, but the glossopharyngeal nerve gives off other branches as well. The glossopharyngeal nerve continues on past the superior and inferior ganglia, descending between the internal jugular vein and the internal carotid artery. The glossopharyngeal nerve becomes applied to the lateral surface of the stylopharyngeus muscle, and together they enter the pharynx through a gap between the superior and middle pharyngeal constrictors. The glossopharyngeal nerve then ends by splitting into its terminal branches. The terminal branches of the glossopharyngeal nerve include the carotid nerve, pharyngeal branches, a muscular branch to stylopharyngeus, tonsillar branches, and lingual branches. The carotid nerve descends within the carotid sheath, carrying general visceral afferent and interoceptive fibers from chemoreceptors of the carotid body and from baroreceptors of the carotid sinus. The pharyngeal branches carry general sensory afferent fibers from the lining of the pharynx via the pharyngeal plexus. The muscular branch supplies special visceral efferent or branchiomotor fibers to stylopharyngeus. The tonsillar branches arise after the glossopharyngeal nerve has entered the pharynx. They carry general sensory fibers from the palatine tonsil and soft palate via the tonsillar plexus. They also carry special afferent fibers from taste buds on the soft palate. The lingual branches carry general sensory afferent fibers from the posterior one-third of the tongue, special afferent fibers from the taste buds of the posterior one-third of the tongue, and general visceral efferent fibers that provide parasympathetic innervation to glands in the posterior third of the tongue. Now we will discuss the 10th cranial nerve, the vagus nerve. Its name is derived from the Latin word vagare, meaning wandering, which is an appropriate name for this nerve as it has the longest course of all the cranial nerves, extending from the head to the abdomen. For our purposes, though, we will only focus on the branches of the vagus nerve in the head and neck. The vagus nerve offers many different modalities of innervation as it wanders, serving diverse functions throughout the body. The vagus nerve carries 5 of the 6 fiber types, including general sensory afferent fibers, general visceral efferent fibers, general visceral afferent fibers, special sense, and branchiomotor. The general sensory afferent fibers carry poorly localized sensation from the epiglottic region, larynx, and upper esophagus. Exteroceptive fibers convey sensation from the small area of skin behind the ear called the patch, and proprioceptive fibers return from muscle spindles and other receptors in the laryngeal musculature, which are important for speech and singing. The general visceral efferent fibers provide parasympathetic innervation to glands of the epiglottic region and to the viscera of the cervical, thoracic, and abdominal regions. The general visceral afferent fibers carry interoceptive information as the afferent limb of visceral reflexes. The special afferent fibers carry taste information from taste buds at the base of the tongue, around the epiglottis, and in the upper larynx. The branchiomotor fibers provide motor innervation to striated muscles of the palate, larynx, pharynx, and upper esophagus, derivatives of the 4th and 6th pharyngeal arches. Now, we will discuss the path of the vagus nerve through the skull. The vagus nerve includes axons from 4 nuclei in the brain. The dorsal motor nucleus of the vagus nerve gives rise to the general visceral efferent fibers, which send parasympathetic output to the viscera. The nucleus ambiguus gives rise to special visceral efferent fibers and some preganglionic parasympathetic fibers. The solitary nucleus receives taste information and afferent fibers from the visceral organs. The spinal trigeminal nucleus receives sensory information from the outer ear, dura of the posterior cranial fossa, and mucosa of the larynx. The vagus nerve emerges from the medulla as a series of fine rootlets and then crosses the posterior cranial fossa, passing through the skull via the jugular foramen. Just below the jugular foramen, the vagus nerve bears its two ganglia. The first is the superior or jugular ganglion, and the second is the inferior or nodose ganglion. The superior ganglion has two branches, the meningeal branch and the auricular branch. The meningeal branch re-enters the skull through the jugular foramen and is distributed to the dura mater of the posterior cranial fossa. It is important to note that there is still debate as to whether the nerve fibers of the meningeal nerve originate in the vagus nerve or in the upper cervical spinal nerves. The auricular branch carries general sensory afferent fibers to the patch of skin behind the ear, a portion of the ear itself, the external auditory meatus, and the outer surface of the eardrum. The auricular branch is given off by the superior ganglion in the jugular fossa. It passes through the lateral wall of the jugular fossa via the mastoid canaliculus. The auricular nerve runs horizontally through the temporal bone and emerges behind the ear via the tympanomastoid fissure. The tympanomastoid fissure can be seen here in a view of the left inferior skull base. In order to locate the tympanomastoid fissure on your skull, turn it over to an inferior view of the skull base. Locate the mastoid process and the external auditory meatus. The tympanomastoid fissure is located on the bone in between those two structures. The meningeal branch and the auricular branch were off of the superior ganglion, but the inferior ganglion also has branches. These include the pharyngeal branch and the superior laryngeal nerve. The pharyngeal branch of the vagus nerve is the primary motor nerve of the pharynx. It descends between the internal and external carotid arteries to reach the pharyngeal plexus. Special visceral efferent fibers pass through the pharyngeal plexus to innervate all the muscles of the soft palate and pharynx, except for tensor villi palatini and stylopharyngeus. The pharyngeal branch also carries general visceral efferent preganglionic parasympathetic fibers to pharyngeal glands via the pharyngeal plexus. The superior laryngeal nerve travels deep to the internal and external carotid arteries, dividing into the internal and external laryngeal nerves. The external laryngeal nerve supplies special visceral efferent innervation to the cricothyroid muscle. The internal laryngeal nerve pierces the thyrohyoid membrane and is distributed to the laryngeal mucosa above the vocal fold, the epiglottis, and the base of the tongue. The internal laryngeal nerve transmits sensory information and taste information from this area. It also supplies general visceral efferent preganglionic parasympathetic fibers to scattered ganglion cells that innervate regional glands. From the inferior ganglion, the vagus nerve descends through the neck in the carotid sheath, traveling in between the internal jugular vein and the common carotid artery. It descends into the thorax and travels to the viscera of the body. Along its path, the vagus nerve gives off several more branches, including the cervical cardiac branches and the recurrent laryngeal nerve. The cervical cardiac branches arise from the vagus nerve in the neck. They carry general visceral efferent preganglionic parasympathetic fibers that reach the heart. The recurrent laryngeal nerves are given off in the thorax and then ascend back to the neck, moving in the opposite direction of the nerve they branch from, giving rise to their name as the recurrent. The recurrent laryngeal nerves carry 4 fiber types: special visceral efferent fibers to the intrinsic muscles of the larynx and striated muscles in the wall of the upper esophagus, general visceral efferent preganglionic parasympathetic fibers to glands in the lower portion of the larynx, trachea, and proximal esophagus, general visceral afferent interoceptive fibers from the heart and airways, and general sensory afferent fibers from the esophagus, trachea, and mucous membrane of the larynx below the vocal fold. Cranial nerve 11 is the accessory nerve. The accessory nerve carries special visceral efferent fibers to 2 muscles, the sternocleidomastoid and the trapezius. The accessory nerve consists of a cranial root and a spinal root. The cranial root arises from the caudal portion of the nucleus ambiguus, the same special visceral efferent nucleus associated with the vagus nerve. The spinal root arises from neurons of the upper cervical spinal cord. This cluster of neurons is sometimes called the spinal nucleus. The spinal root ascends through the foramen magnum and traverses the posterior cranial fossa to converge with the spinal root in the skull. Together they pass through the jugular foramen. They diverge again immediately below the base of the skull. The cranial root of the accessory nerve blends with the vagus nerve after passing through the jugular foramen, becoming its accessory. Thus, in terms of motor innervation in the head and neck, it is best to consider the vagus nerve and the cranial accessory nerve as a single entity. After the cranial root of the accessory nerve diverges from the spinal root at the base of the skull, it descends along the internal carotid artery to reach the sternocleidomastoid. It continues moving across the posterior triangle of the neck to supply the trapezius. There is dispute as to whether the motor innervation is special visceral efferent or general somatic efferent in nature. But for our purposes, we believe that the spinal root of the accessory nerve provides special visceral efferent innervation to the sternocleidomastoid and the trapezius muscles. The hypoglossal nerve is the 12th cranial nerve. The hypoglossal nerve carries general somatic efferent fibers to all the intrinsic and extrinsic muscles of the tongue, except for palatoglossus, which is innervated by the vagus nerve. The hypoglossal nerve originates from the hypoglossal nucleus in the medulla. The hypoglossal nerve arises as a number of small rootlets from the medulla. It passes across the posterior cranial fossa, traveling in the subarachnoid space, exiting the skull through the hypoglossal canal. Once the hypoglossal nerve exits the skull, it receives fibers from the C1 spinal nerve. These fibers do not combine with the hypoglossal nerve, they just travel within its sheath for distribution to the muscles of the neck. The hypoglossal nerve travels inferiorly to the angle of the mandible, crossing in front of the internal and external carotid arteries. It travels deep to the muscles of the floor of the mouth, moving anteriorly to reach the tongue from below.